When installing electrical wiring within conduit systems, understanding and adhering to both conduit fill requirements and the markings on junction boxes, specifically LB, is paramount for safety and code compliance. The question often arises which set of rules takes precedence when there's a discrepancy between the number of conductors permitted by a conduit fill chart and the number specified on an LB fitting. The general principle is that you must always adhere to the most restrictive requirement. This means that if a conduit fill chart allows for a certain number of conductors of a specific size within a particular conduit size, but the LB fitting connected to that conduit is marked with a low maximum conductor capacity, you must follow the LB marking. Let's delve deeper into why this principle is in place and how it applies in practical scenarios. Firstly, conduit fill charts, such as those found in the National Electrical Code, specifically Chapter 9 and Annex C, dictate the maximum percentage of a conduit's cross-sectional area that can be occupied by conductors. These charts take into account factors like heat dissipation, ease of pulling conductors, and the prevention of damage to the conductor insulation during installation. The NEC tables provide guidance on the allowable number of conductors based on their size and type, as well as the type and size of the conduit. Secondly, LB fittings are types of conduit bodies, which are essentially specialized junction boxes used to provide access to conductors within a conduit run. They are frequently used to make bends and conduit pathways allow for easier wire pulling or provide a point for future circuit modifications. LBs, like other electrical fittings and equipment, are marked with specific information, including the maximum size and number of conductors that can be safely and effectively accommodated within the fitting. These markings are determined by the manufacturer and are based on the LB internal volume, the geometry of its wire bending space, and the need to ensure adequate heat dissipation and prevent overcrowding. When an LB is marked with a maximum conductor capacity that is lower than what the conduit fill chart might suggest for the connected conduit size, it's typically due to one or more factors. One factor is the physical space within the LB. LB are often smaller than standard junction boxes and have limited internal volume. Cramming too many conductors into a small space can make it difficult to make proper connections, increase the risk of insulation damage, and impede heat dissipation. Another factor is the bending radius of the conductors. When conductors are bent sharply, especially larger gauge wires, the insulation can be stressed or damaged. LB are designed with a specific internal geometry to accommodate conductors bent to a certain radius. Exceeding the LB maximum conductor capacity can force conductors to be bent beyond their safe bending radius. Thirdly, heat dissipation is a critical consideration in electrical installations. Conductors generate heat when current flows through them. The amount of heat generated depends on the current, the conductor size, and the ambient temperature. The NEC specifies opacity ratings for conductors, which are the maximum currents that conductors can carry safely under specified conditions. These opacity ratings are based on the assumption that the conductors are installed in a way that allows for adequate heat dissipation. Overfilling a conduit or an LB can impede heat dissipation, causing the conductors to overheat and potentially leading to insulation breakdown, short circuits, or even fires. Here's how to apply the principle of adhering to the most restrictive requirement in practice. Suppose you're installing 4 number 2 GHHN conductors in a 1 1/2 inch rigid metal conduit. According to a typical conduit fill chart, this configuration might be permissible. However, if the LB fitting you're using is marked with a maximum conductor size of 3 number 2 American wire gauge (AUG) conductors, you must follow the LB marking and reduce the number of conductors to 3. You have several options to resolve this discrepancy. One option is to increase the size of the conduit and LB fitting. By using a larger conduit and LB, you can increase the available space for conductors and potentially accommodate the 4 number 2 AWG conductors while staying within both the conduit fill chart and the LB marking. Another option is to use a larger LB fitting. Even if you maintain the same conduit size, using a larger LB with a higher conductor capacity may allow you to install the 4 number 2 AWG conductor safely and in compliance with the code. Thirdly, you can reduce the number of conductors. If it's not possible or practical to increase the conduit or LB size, you may need to redesign the circuit to reduce the number of conductors required. This could involve using a different wiring method, such as running multiple circuits in separate conduits. Fourthly, consider using conductors with a higher temperature rating. While this doesn't directly address the LB marking issue, using conductors with a higher temperature rating, such as THHN THWN-2, can increase the ampacity of the conductors and potentially allow you to reduce the conductor size, thus requiring less space in the conduit and LB. Fifthly, consult with a qualified electrical inspector or engineer. If you're unsure about the correct way to install conductors in a conduit system with LB fittings, it's always best to seek expert advice. A qualified electrical inspector or engineer can review your plans, assess the specific installation conditions, and provide guidance on how to comply with the applicable codes and standards. It's important to note that the NEC is a comprehensive document, and its requirements can be complex and subject to interpretation. Local jurisdictions may also have their own amendments or interpretations of the code. Therefore, it's essential to stay up to date on the latest code requirements and to consult with local authorities to ensure compliance. In addition to adhering to the most restrictive requirement between conduit fill charts and LB markings, there are other important considerations to keep in mind when installing electrical wiring in conduit systems. Firstly, always use the correct type and size of conduit for the application. The NEC specifies different types of conduit for different uses, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages in terms of cost, weight, strength, and corrosion resistance. Secondly, use proper fittings and connectors. Conduit systems rely on a variety of fittings and connectors to join conduit sections, make bends, and connect conduit to electrical boxes and equipment. It's essential to use fittings and connectors that are listed for use with a specific type of conduit being installed and to install them according to the manufacturer's instructions. Thirdly, support conduit properly. Conduit runs must be adequately supported to prevent sagging, damage, and strain on connections. The NEC specifies the maximum spacing between conduit supports, which varies depending on the type and size of conduit. Fourthly, pull conductors carefully. When pulling conductors through conduits, it's important to use a lubricant to reduce friction and prevent damage to the conductor insulation. Avoid pulling conductors too hard or kinking them, as this can damage the conductors and make them difficult to work with. Fifthly, ground the conduit system properly. Metal conduit systems must be properly grounded to provide a safe path for fault current. The NEC specifies the methods for grounding conduit systems, which typically involve connecting the conduit to the building's grounding electrode system. Sixthly, inspect the installation thoroughly. After the conduit system is installed, it's important to inspect it thoroughly to ensure that all connections are tight, all supports are in place, and there are no signs of damage or defects. By following these guidelines and adhering to the NEC and other applicable codes and standards, you can ensure that your electrical installations are safe, reliable, and compliant. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable performing the work yourself. Always energize circuits before working on them and use appropriate personal protective equipment such as gloves and eye protection. Understanding conduit fill and LB markings is crucial for ensuring the safety and reliability of electrical installations. By following the principle of adhering to the most restrictive requirement, you can prevent overfilling conduits and LB, which can lead to overheating, insulation damage, and potential fire hazards. Always consult the NEC and other applicable codes and standards and seek expert advice when needed. In summary, when faced with a situation where the conduit fill chart allows for a certain number of conductors, but the LB fitting is marked with a low maximum conductor capacity, you must always follow the LB marking. This is because the LB marking takes into account the fitting's physical limitations, bending radius constraints, and heat dissipation capabilities, all of which are critical for ensuring a safe and compliant electrical installation. Remember that electrical codes and standards are in place to protect people and property from electrical hazards. Adhering to these codes and standards is not just a matter of compliance, it's a matter of safety. By following the guidelines outlined above and consulting with qualified professionals when needed, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable regulations.